Okay, so we move on to question 14. We have an object A of mass 2 kg. We suspend from a pulley B by a light string. Okay, the rough pulley has a radius of, this pulley have a radius of 20 cm, so it's 0.2 meter. And the moment of inertia I for the pulley is 0.04 kg meter squared about the axis of the pulley. So object A is released from rest. So we understood when object A is released from rest, the initial velocity of object A is 0 because from rest, and the pulley start to rotate without encountering frictional force. So we doesn't have any frictional force acting on the pulley. The only force that act on the pulley is the tension. So the only force acting on the pulley is the tension in the string. The tension in the string, okay, that will rotate, create taut and rotate the pulley. So assume that the string do not slip on the pulley. After time 0.5 seconds, we want to determine the linear acceleration of A. So we want to find A, the linear acceleration for object A, because object A is doing linear motion. So we understood the object A is perform linear motion and the pulley is doing rotational motion. Okay, so we want to find the angular acceleration alpha of the pulley. So the pulley have angular acceleration because it's performing rotational motion. The tension in the string, so we want to find what is the tension in the string. The linear velocity of object A, so the linear velocity of object A means the final velocity lah, because after time 0.5 seconds, the vertical distance traveled by A, so means the linear displacement for object A. So in order to solve this question, because you want to find for the linear acceleration, so this linear acceleration we can calculate by relating the rotational motion and linear motion. So maybe we consider about object A first, because you want to find for the linear acceleration of object A. So we understood object A is doing linear motion. So I consider object A, so I draw the FBD for object A. So we understood object A is attached by the string, so it have tension upward, then it have mass downwards, so it have mass, so it have weight downwards, whereby the weight can relate with the mass of the object, W equal to mg. So object A is accelerate downwards. So taking the direction of acceleration as positive, apply Newton's second law, summation force equal to ma. So I'm going to have mg minus tension equal to ma. So the mass of the object is 2, g is 9.81, minus tension equal to 2a. So again, I have two unknown, the tension and also the a. So I try to put it as my first equation. So 2 times 9.81, it will be 19.62 equal to 2a. I move the negative 2 to the right side, so it becomes positive t. So I put this as my first equation. I cannot solve the question because A is unknown, tension is unknown. So doesn't matter, we have another object whereby we have pulley. So we consider the rotational motion for the pulley. So for the pulley pulley, tangential to the pulley, we have tension in the string, whereby it have a distance r from the axis of rotation. So this tension create torque. So apply Newton's second law for rotational motion. Summation torque equal to I alpha. So the distance is r, tension is T. So the angle between the distance, okay, I highlight it so you can see it clearly. So this is the distance from the axis of rotation. This is my tension. So you can see very obviously the angle is 90 degrees. Okay, so the moment of inertia is given. The moment of inertia for the pulley is 0.04, and then this alpha angular acceleration we can relate with the linear acceleration A, whereby alpha is A over R. So the R is, okay, R, A over R. Okay, then I put in all the value. R is 0.2, tension T, sine 90 is 1, okay, so 0.04 divided by 0.2 times A. So I'm going to have 0 equal to 0.04 divided by 0.2. It will be 0.2A. So 0.2T, I move it to the right. So I have minus 0.2T. So this will be my second equation. So class, use your calculator. Use the simultaneous equation in your calculator. You can solve the both equation to get the value of A and also T. So I can calculate A and I can calculate the tension. So I'll get the answer for question A and question C. Terus. So kita cuba calculator. Equation mode, equation mode 5. So first one, 2 unknown, so 2, 1, 19.62. Second one, 0.2, 0.2. Oh, sorry, I have a negative sign in front. Okay, then 0. Okay, so I get my first unknown A is 6.54. Okay, 6.54 meter per second squared. Okay, how about the second unknown? Second unknown represent tension. Oh, it will have the same value. Okay, doesn't matter. 6.54 as well. Right, second unknown, tension. So the unit for tension, force is Newton. So I already get the answer for question A and question C sekaligus. Then I solve, so I write it down. This is answer for question A. This is answer for question C. Then I try to solve question B. So I want to find the angular acceleration alpha. So this alpha I can relate with A. How we relate rotational with linear motion? A is R alpha. Still remember? We learned it during the first hour of our tutorial session. So our A is 6.54. The R is 0.4. 0.2. So sorry. 0.2. Okay, 0.2 alpha. Okay, then I can calculate the alpha. So my alpha will be 6.54 divided by 0.2. So I get my angular acceleration will be 32.3. 32.7 radian per second squared. Okay, then I solve question B. Question D. the linear velocity of A. So we understood the object A is released from rest, so initial velocity is 0. So the acceleration experienced by object A is already calculated from question A is 6.54 meter per second squared. Then after time 0.5 second, I want to determine the speed, the final speed of A. So I can use kinematic equation V equal to U plus AT. I use kinematic equation because object A is perform linear motion. Okay, so I'm going to have 0 plus 6.54 times 0.5. So I'll get the speed of object A after 0.5 second should be how much? Let's calculate. We get, okay, 3.27 meter second negative 1. Okay, done. Then question E. So question E, I put it here. Okay. Question E, I want to find the vertical distance traveled by A. So A is perform linear motion. I want to find S. So I can use kinematic equation. S is ut plus half AT squared. So U is 0. So kosong darab apa pun kosong. So half A is 6.54. The time is 0.5 squared. So I'll get my S. You might pause the video to do the calculation. Sorry, half is 0.5 times 6.54 times 0.5 times 0.5. Darab 2 kali sebab kuasa 2. So I'll get the distance is 0. Okay, I round it off to 2 decimal place. 0.82 meter. Okay. Then we solve question E. I guess we have another question teacher left out just now. We have question F, I guess. We want to find for the angular velocity of the pulley. We want to determine the angular velocity of the pulley. So angular velocity is omega. So we want to find for omega. So the pulley is doing rotational motion. So this angular velocity can relate with the linear velocity. V is r omega. So we can determine the angular velocity. Omega will be V over r. So our velocity is 3.27 divided by the radius, the r of the pulley, 0.2. So I'm going to have 3.27 divided by 0.2. So I get 16.35. Okay, 16.35 radian per second. Then we're done with all the question in question 40. Okay.